Okay, we'll continue with the next presentation at the EasyBuild user meeting. That will be Shazeb Siddiqui talking about his Buildtest project. Take it away, Shazeb.
Thank you, Kenneth. And I'd like to thank the EasyBuild community for organizing this event, especially Kenneth. This has been a interesting experience. Doing this virtual. So anyhow, if you don't know me, my name is Shazeb Siddiqui. I work at Lawrence Berkeley as an HPC consultant. I'm part of the user engagement group, so we take care of user support tickets and documentation training. I'm also part of the ECP project, so we in the software deployment group where we're responsible for like building Spack E4S stack. And as part of this talk today, I'll be giving overview of Buildtest. And it's kind of funny. It started out as a project when I previously used to use EasyBuild. It didn't have support for like software testing. So we'll talk about Buildtest and also some of the current testing updates regarding E4S Test Suite. I'll talk about that. And just a summary of what updates last year that we've done. So let's get started. So talk about what is Buildtest. So it's a HPC testing framework for like the facilities to basically write acceptance tests and for their target system. And Buildtest is open source. You can find the documentation on the right. It's also on GitHub, and Buildtest is target audience is like HPC staff. The goal is to help the team to be able to gain confidence that their system is working as operational. Acceptance test requires like periodic testing. Typically as a facility, you would do this as part of a maintenance outage, and make sure that you try to test as much parts of the components as you can. One of the key features is that we want to make writing tests easier. So pick YAML as the front end for writing tests, and we validate them using JSON Schema. Okay, and there's also the need to have automation in order to create these tests and run them efficiently. And I wanted to mention that Buildtest is is targeting system and software testing, so it's not like a software build framework like like EasyBuild or Spack, which are good for installing software. So it's not that, and it's not like kind of like a build tool like CMake. Well, and yeah. So we picked YAML and JSON Schema, and there, YAML is pretty easy for users to get started, and it's actually been widely used in many open source projects. Just to name a few like Travis, Ansible, GitLab, CI, even GitHub Workflows, Kubernetes, they all use it. And JSON Schema is a vocabulary that helps annotate like JSON documents. JSON and YAML are like kind of interchangeable, and in Python they're both like represented as a dictionary, so it makes it easy for us to like convert data. So we use JSON Schema to help validate the test, but we write the test in YAML. And on the right, you can see kind of one of the examples. This is of a Docker Compose recipe. It basically uses like this version-based schema, if you're familiar, to write this. And Buildtest kind of has like the similar concept of using like a version-based schema to allow like writing tests, but having further development of schemas. So it'd be like you pin to some specific version and then you write tests. And yeah, one of the major updates that happened at least last year was the introduction of JSON schemas, and this was a core change in how the framework previously was done. It used to validate tests through its own validation process, and now using JSON Schema, we are able to do a lot more kind of rich syntax in YAML. One of the things that we have is we publish the JSON schema in GitHub pages. So on the bottom left is the schema documentation. We publish the example test for each schema, including the markdown pages that document each schema, and also the schema files themselves. And it's really nice. On the right is kind of one of the example schema. This is the compiler schema. These are auto-generated markdown pages, basically translating the JSON schema using this workflow called JSON schema to markdown. And then we just publish them into GitHub pages. And the way it looks, when you're writing tests, you can see all the type properties and their description, and it helps you kind of easily see what each property does. Now we'll talk about the command line usage for like typically building a test. In Buildtest, it's called Buildtest build, and you can specify a file using like the -b option, and it will like build from a single file. You can also build like all your tests using like if you specify a directory. If it's a directory, then Buildtest will just traverse the whole directory structure, find all the .yaml files, and build them. You can also append the -b option multiple times, so it could be a file or directory. You can also build by tags. So this concept of having like a keyword string to search for tests, like you classify tests by, let's say, network tests. You can use at least tag names to search for tests and build them. You can also like build, like for instance, a whole directory and then like exclude files or directory using the -x option. And that can also be appended multiple times. So it's useful like if you want to build an entire directory, but like exclude one subdirectory or something like that. Here's just an example of output. This is an input test. We're using the -b option. We have a single file. It's basically a Python hello world example. The first thing that it does is Buildtest will discover the build specs. That's what these tests are called. And it will, once it discovers, it will try to parse every single one through schema. That includes two schemas, actually, global schema and a sub schema. In this example, the schema is using script version 1.0 to validate the test. If it passes the parse stage, then it will actually build the test. We can see the test name is Python hello. Buildtest will generate a unique ID, and it will generate the test like the shell script, and then actually run the test. Typically, the output will give you a return code and also like a status message. That's like that could be either pass or fail. Now you can also build by tag. So this is just an example of building by a tag name called pass, and it will discover the build spec. In this example, it found that there was one test. In that one test, it had four tests within it, and it just basically runs all of them together. So we'll talk about the pipeline. For every discovered build spec in Buildtest, we go through like this 5-stage kind of pipeline. The first is we parse the build specs into with the JSON schema, and this includes basically just a validation of the file itself before we actually build the test. And during the build phase, we actually take this the script and the YAML file and actually generate a valid kind of a shell script. And then we finally run the test via what's called executors. And think of executors as like basically could be a local executor, so it runs locally, or a batch executor, so it could be mapping to a queue in your scheduler. Once we run the test, we get the output, error file, and the return code. And finally, we update the report, which includes like getting all the metadata and test result, and just storing it internally in basically a JSON record. So we'll talk about in this diagram is the build spec validation process that's done during the parser stage. And imagine you have this input build spec. First thing to note is that Buildtest has like a schema library or what's called like, the supported schemas. Currently, we support what's called a global schema. And we have two primary schemas for the test. It's the script and compiler. And those schemas are actually version schemas. The settings schema is for the Buildtest configuration. So that's just another schema. So in this diagram, what happens is you have this input build spec. The global schema is used to validate for every build spec. And it validates the kind of the outer level structure, meaning in this example, it will validate the version and the build specs. These are required properties by the schema. Maintainers is just an optional field, but it will validate that. The version is required because it uses it to pick up the appropriate what's called a subschema. And the type field is used to, is a lookup to find the appropriate schema. So currently we support script and compiler. So with the version, we're going to use the script version 1.0 schema to validate the section. The test section, which is in this green box, is the hello world kind of test. That's validating each test instance. So now let's dive into the actual structure of the test. So what each of these properties do. So the first is the version. This is a version that defines the schema version to use. And currently that's set to version 1.0. So, as in the future, when the schemas have newer functionality and versions, then you can change this property. Build specs is like the declaration of like one or more tests. In this, you define just some unique test name. So the test name is called systemd default target. And that's the name of the test. The executor and type are required fields. Executor tells which executor you're going to use to run this. The type is the name of the schema to use. You can attach a short description of the test. The tags is just a list of strings to classify how the test is. If you want to use the tag feature to build the test, and then the run is just a script section. It could be a multi-line string or a single string, and that's where you define the content of your test. One other feature that we have is we can actually control how the build stage is using the stage option. So when you're writing a test, sometimes it would be useful to actually just parse the build spec or just build it, but not actually run it. So you can use this stage option, and it accepts either parse or build as the options. So in this example on the right, we just use that. Just stop after the parse stage, and it will just tell you if the build spec is valid or not. And that's pretty useful when you're developing your test. We support return code matching. So by default, a return code 0 is a pass in Buildtest. However, sometimes you want different return codes because you may be testing like an actual failure test, and you may have different return codes. So in this example on the left, we have 4 tests, right? So in the build specs, if you can actually define multiple tests. So we have 4 tests: exit 1 fail, exit 1 pass, return code list mismatch, and return code int match. The first one is an exit 1 fail. So it's going to get exit 1, so it will be a fail. So you can see that on the red. The second test, it's going to get an exit 1, but we're going to say in the return code property a list of each return code. So we say we're going to expect a 1, so it will pass. In the third test, we're going to get an exit 2, but we're expecting a list of return codes, 1 or 3. So it kind of build test will look if the return code is in the list, and if it's not, then it will fail. And the last test, we got a 128, and we were going to expect 128. So you can do multiple return code. I mean, you can validate your test through different return codes to control like how the test is going to pass. We support different shell properties to customize how the test is run. So the shell property by default is bin bash, the system bin bash, but you can say I want to use different shell. So you could use bin sh, bash sh. You can use csh, tcsh, or even Python. You can also pass in options to it, to the shell property. On the left is just kind of the description of the property itself. So that from the markdown from the schema docs. So it tells you exactly what the property, what it does, what the type is, and even a pattern matching. So it's pretty useful. So following to that, you can use Python shell, using the shell property to write Python code. So all you need to do is say change the shell to Python, and your run section where you actually define your script can be used to write Python code. And it's pretty easy to do like simple Python code. Like if you have like your own Python scripts, you can certainly just invoke the Python script using like a bash or sh shell, and just change the shell name. In terms of scheduler, we support LSF, Slurm, and Cobalt. And one feature that we added was having scheduler agnostic configuration through this property called batch, where if you don't want to know like the inner details of the scheduler, like the options itself, the batch property provides a set of fields that kind of map to different schedulers, and the goal was to help kind of provide an interface between different schedulers in terms of the option. And we only implement obviously features that are common between schedulers. Currently, like for instance, like time limit is kind of provided by all the schedulers. So the field name is called time limit, but in Slurm is called time, in LSF is W, and Cobalt is -time. And this is just an example of a test that is using Slurm. So we can specify the node count, CPU count, time limit, and it will just convert all of them into SBatch directives. We also support Cray burst buffer and data warp. So if you have a Cray system, you may be familiar with BB and DW directives. And in this example, like what we have is we have these properties called BV and DW for defining the directives. We have this what's called in this example, we're creating a persistent data buffer, of 10 gigabytes, and it's striped axis. And in the run section, what we have is we're just going to create a random txt file, of 1 gigabyte block size, 5 times. And if you see in the output, the random txt file is actually in the burst buffer directory. And yeah, so, and since this is a persistent burst buffer, like you would see the output of the burst buffer after job termination. So you can do like scontrol show burst, and you will see the burst buffer. So everything that we talked about before was the script schema. Now we'll talk about compiler schema. That's the using the type compiler property. This is an example of basically compiler selection and the defaults that you can set for compilers. We have this what's called an example of a vector addition using GNU compiler. So note that when we change the schema, we'll have different properties because we're going to validate with a different schema. So for instance, source is a required property. It tells you the source file to use to compile your code. The compilers is the start of the compiler block. And in this block, you have to specify the compilers to use. The compilers are actually defined in your configuration file in Buildtest configuration. So you can actually find it using like Buildtest config compilers that you see on the right. So we have 3 compilers. And you can specify the regular expression in the name property. So I want to say I want to find all compilers starting with GCC. The default is a section that's organized by compiler groups. So you can and you have a section for GCC where you can define compiler flags like C flags and LD flags. And basically this test will actually run for both GCC 10 and 9. So now let's dive into some more examples. This one, you can actually you can override compiler defaults. So we have this example of so in our regular expression, we're going to build with built-in GCC and GCC as the compiler. So there will be 3 tests. This is basically an hello world C example. The source file is hello.c. And in the default, we say that for GCC, we're going to use -01 for the compiler flags. However, we want to override maybe the compiler flag. So we can use the config section and specify a configuration based on each compiler name. And you define the compiler name that you want. So GCC 9.3.0 will use -02, and GCC 10 will use -03. And what Buildtest will do is, if the compiler is searched during the if it finds it in the regular expression, then then it will just apply the configuration. If it doesn't find it, then it will just be ignored. So, and in addition to this, we can actually do like, imagine you have a single test, but you want to compile with multiple compilers. So, this is an example of an OpenMP reduction example using GCC, Intel, and Cray. So all you need to do is first specify the regular expression. So depending on how your compilers are set up in your configuration. So we say anything that starts with GCC, Intel, or programmed Cray. That's just how the compilers are defined. We introduce a new property called all that tells how the it's compiler configuration that's inherited by all the compiler groups. And environment is just a property that just tells to define environment variables. So we just say we want to use 4 OpenMP threads. And in each of the compiler blocks, like GCC, Intel, and Cray, we can define how to actually compile the program. As you can see in this test, this reduction test was compiled with all the GCC, Intel, and programmed Cray. So that's pretty useful. So now we'll talk about some other features in Buildtest. Like, for instance, the first thing you can do is you can actually load all your build specs into a cache using Buildtest buildspec find, and then you can actually filter and format these cache. So if you want to like search for tests, that's the whole goal. That's the primary use of this command. So in this example, we can actually filter the tests using different properties. So like I want to query by the tags property in the test and say find me all the tests with a failed tag, and it will show you all the tests. So we see there's 2 tests. In this second example in the middle, you can actually format the columns. So by default, we give you like 5 columns, I think, like name, type, executor, tags, and description. But you can customize how the columns are for printing. So for instance, I want to only format by name and tags, and it will just show it to you. The format option expects the format fields to be delimited by a comma, and it will just print them in the order that it was specified. And then you can also filter by different or multiple key filters. So in this example on the bottom, you can actually filter, let's say, by tests that are like of tags that are tutorial and executor that use local SH and using the script schema. And it will kind of do a logical and filter. And if you want to know the different filter and format options, you can use help filter and help format. So as you build tests, they get reported into a JSON file. And you can use Buildtest report to actually display the test results. And similar to the previous slide, we have filter and format option that behave very similar, but they have different field attributes. They both expect key value pair and separated by comma. So the filter in this example, let's look at the one in the bottom left. Like you can filter by a name, the test name. So say like I want to filter by exit one pass. So it will show you all the tests. And you can also format by different columns. So you can also filter by return code. So in this example, in the bottom right, you can say, find me all tests with a return code 2. And it can be any return code value. It has to be an integer. And then you could also filter by multiple keys. So the state property tells you if the test actually pass or fail. So that is a really useful one. So you could say, I want to find all tests that fail, but only on an executor, only that use the executor local SH. Okay. Now we'll talk about some of the testing capability that we have in Cori Testsuite. So you can look at the link below for all the tests. We just basically try to test various components of Cori system, including system, network, file system. We try to test for if all the login nodes are available, using ping or SSH. Sure that since we use Slurm, we want to test basic Slurm commands like like sinfo, sq. Make sure the controllers are up, partitions are available, submit jobs to all the queues. Make sure like burst buffers, we can access a burst buffer. On the application side, we test different apps like OpenACC, OpenMP, like Stream. We use Shifter for like the container runtime, so make sure we can pull images through Shifter, and the E4S Test Suite, which is like the Spack stack. This is just an example of one of the tests. So it's just testing SSH ping and uptime. On Cori, we have 12 login nodes, Cori 01 to 12. So we just make sure that we can ping them. We have 6 data transfer nodes, DTN 01 to 06. We just make sure that we can run uptime against all the nodes and just run SSH against all the nodes and just run some command. So it's pretty pretty simple way to actually write tests. Next, we'll talk about E4S, Test Suite on Cori. First, talk about what is E4S. E4S is extreme scale scientific software stack. It's basically a collection of Spack packages, and these are built and tested on several platforms. And E4S is deployed as a Spack manifest. At least that's what we use, but it's also deployed as a container and build cache. And the one that we're interested in is the E4S Test Suite. This is the collection of the tests that's used to validate the E4S stack, basically to increase confidence in the deployed stack. If you clone this repository, what happens is there's a script called testall.sh that's used to run the test. So all you need to do is clone Test Suite and then source some Spack environment, source their setup script, and then you can test a particular application. The tests are in validation test directory. So this is just an example of qthreads test that's run. So what we've done, I believe in January, this month, we deployed E4S on Cori. It had up to 135 specs. And you can see the link for the documentation over here. The idea is we want to leverage basically the E4S Test Suite to validate parts of the E4S stack. because it provides majority of the tests. But we have integrated that like into the Cori Testsuite so that it can use Buildtest to actually run all the tests and have all the other tests that we have outside of E4S. We make use of GitLab to run the test through automated like schedule pipeline. And for the next release, we can like utilize like Spack tests to also run tests. So basically leverage other tools to run tests. But we also want to be able to develop site-specific tests, that go through our custom modules and queuing system. To run the test, you just use the tags E4S. That's how we just classify the test. And what we have done in order to customize this, we have a custom executor. It's in our configuration. What it says is that this E4S property is the executor name, and the options is just the Slurm kind of options that used to submit the job. So we're going to use a regular queue KNL partition with a -t is at 10 minutes. And the before script just tells the script to be executed for before running any tests that associated to this executor. And the idea is just basically to source the Spack environment and the test suite setup script. And on the right is just an example of the of a test. This is an adios test that uses the E4S Test Suite to run the test. I'm not going to go over this in too much detail, but this is an E4S pipeline that we had. It's available in Spack configs repo. It was recently added. But what I wanted to just mention is that we built the Spack stack using the Spack CI generate to actually get the GitLab to actually build the Spack jobs in parallel. That's in this this generate Spack pipeline and the build E4S job. And then finally, at the end, we actually do like post installation tests. In this example, we just use Buildtest to actually clone the repository and just run Buildtest on the E4S tags to actually run all the tests. And finally, at the end, like we just report the test results. So this was all done in GitLab. Just some updates, at least for last year. We introduced JSON schema for validating build specs and the configuration. The JSON schemas were published to our schema docs. We removed the build test module features into the L module project, which we'll talk about next. And the regression tests, we moved them from Travis to GitHub workflow because it just works much faster. And we added support for Slurm, LSF, and Cobalt. And yeah, we moved the organization, at least from HPC build test to build testers. And we also recently added a GitLab CI check to run regression tests on Cori. And yeah, and then, just to wrap up, this is my last slide. Buildtest is, a testing framework. It's there to help the facilities to actually write tests. The users just need to know basic understanding of YAML. And Buildtest is not like a test suite. Facilities will still need to develop their tests, appropriate for their system. And if you want to get started, like we have I think up to 100+ tests in the Cori Testsuite. And if you need help, you can just please join the Slack. It's a self-invite, or if you want to post issue. And then the references are there for your help. Thank you.
Thank you, Shezeb. We have time, I think, for one question here, and there will be plenty of time after Shezeb's next talk on L module, which is right after this one. So if somebody has a question right now, we can take it now. So raise your hand in Zoom or drop it into the EasyBuild Slack channel. Maybe I have a quick question, Shezeb. Do you have any examples of collections of tests other than the ones you've showed? So are there any sites actively using Buildtest and sharing their tests with the community?
So right now the Cori Testsuite is available on the same Buildtest organization, so it's like available there for public. I had also set up an organization on Stampede, like over there, to actually run tests. However, it's hard to like, I mean, I think it's like easy for people to like look at other sites and start seeing how they do the tests. There are generic tests in Buildtest, like when you clone it. I guess anyone can just write the tests there. But yeah, I think it's mostly like you just have to look where the tests are and go from there. There are some tests that I have. Yeah, I mean, I think in OLCF and yeah, but I mean they're not right now public.
Okay. Okay, I don't see any other questions right now on Buildtest, so we'll wrap things up here and get ready for the Elm module talk.